are great demands for electric power, power for industry, transportation, and light, the countless electric devices which will expand that to unlimited horizons in the future.
So y'all are probably really aware of this already, but we are in revolutionary times when it comes to electricity and electronics. Never in the history of Homo sapiens have we ever had this much access to products that allow us to be this self-reliant. The ability to buy consumer versions of these green power sources is so exciting. It's so exciting! Today I'm going to show you guys how I put together my simple solar setup, as well as teach you some terms that are going to help you become a self-reliant, revolutionary badass.
I'm by no means an expert or professional when it comes to this stuff. Practice caution when working with electricity, and do as much research as possible before attempting any of the following.
You might feel like you need a lot of items in order to build your setup, but I can tell you it's a lot simpler than that. I also felt like there were a lot of items that I needed. The following are some products that you're going to need in order to build a setup similar to mine. First of all, you're going to need some sort of power generating source, and that can come in the form of solar panels, a wind turbine, a water turbine, or an isolator relay that goes from your car battery to your house batteries.
The unit you need to know when choosing your power source is watts. Watts is a measurement of power. If you think about it as the flow of water through a pipe, it is the amount of water that is able to be pushed into your sink at any given time. A 100-watt solar panel, for example, is able to slurp up 100 watts of sun energy at any given moment in time to be stored by your batteries.
Second of all, you're going to need a large capacity battery. I use an AGM deep cycle battery because they are sealed and maintenance free. Any type of large battery will do, but I definitely recommend a maintenance free battery. You don't want to have to be messing around with any battery acid or anything like that.
The way battery size is measured is in amp hours. Depending on the type of battery you buy, it will tell you how much you can deplete the battery. Think of a battery like a bank. If you have 200 amp hours in your battery bank and you use 1 amp per hour for 10 hours, you will have 190 amp hours left to use given you aren't taking in any energy. You should also take into consideration the type of battery's discharge limit. For example, I have a 200 amp hour battery. Because it is an AGM battery, I really should only ever drain it down to about 50%. This gives me 100 amp hours to use when fully charged. I highly recommend doing more research on this topic and discussing your options with your battery retailer. Now, how do you figure out how many amp hours you're going to need and how many watts your power source is going to need to provide? Start thinking about the things that you want in your setup and make a list of them. I have linked below a spreadsheet that you can download and input your appliance to calculate an estimate of how much power you're going to need.
The third thing you're going to need is a charge controller similar to this one. What you need to know is that there are two different types of charge controllers, a pulse width modulation charge controller or MPPT charge controller, which is a maximum power point tracking charge controller. I don't know if they still sell pulse width modulating charge controllers, but if they do, they're going to be on the cheaper side, but it is a technology that is a lot older than an MPPT charge controller. So I highly recommend spending the extra money and buying a MPPT charge controller because it's also going to boost all of the power input that is coming into your battery. So that's pretty cool. It's definitely worth the money. Fourthly, you're going to need a fuse box. I use a marine fuse box because it makes everything a lot neater and easier to see. And it's really easy to change the fuses if they decide to break. It's pretty cool.
To choose a fuse size, it can be helpful to understand the unit amps and volts. Thinking back to our pipe analogy, amps can be compared to the volume of water that is flowing through the pipe. It is the rate of electricity moving through the system. Volts can be compared to the pressure that is forcing the water to be pushed through the pipe. We are working with a 12-volt system, so that means that electricity is going to be conducted through a wire at a force of 12 volts. When choosing a fuse size, the amperage your product requires and the fuse should match. Most products will tell you its amperage usage, but just in case you need to know, look up the amount of watts your load pulling hardware requires. Then divide the amount of watts by your system's voltage size. For example, my max air fan requires 60 watts. My system's voltage size is 12 volts, which means I need a 5 amp fuse. If the fan somehow pulls more than that, it will break the fuse, breaking the circuit, thus saving your appliance.
The next few things you're going to need are load pulling hardware, black and red 12 gauge wire, dimmers and switches like this one, an optional main switch, and an inverter that converts from DC to AC that can handle the amount of watts that you plan on using all at the same time. I don't have one of those yet because I haven't ordered it, but we can pretend it is in my arms and I'm cradling the sweet, sweet power juice baby in my arms. Now I know that was a lot of information, but I put all of the time codes down below in order for you guys to be able to refer to them later on. So now we are going to put it all together. Since my system isn't really complete yet and I don't have all of the parts that I want, I'm going to use drawings to help explain this. I know y'all probably already know the difference between alternating current and direct current, but I think before we get into everything, it is important to understand the differences and the pros and cons of both.
An AC or alternating current uses positive, negative, and ground wires and runs at 120 volts for the system, but varies from country to country. It is called alternating current because it creates a sine wave moving from positive 1 to negative 1 in a frequency of cycles per second. This is the frequency you use in an on-grid system. DC, or direct current, uses a positive and negative wire only, and comes in smaller voltages like 5, 9, 12, 24, and 48 volts. Direct current is awesome because it goes from your battery straight to your appliances, where an AC appliance requires you to have an inverter, which takes up way more power to convert from DC to AC back to DC again. I try to steer away from as many AC appliances as possible, but sometimes you just can't avoid it. It would be really cool if they started developing more 12-volt versions of everything.
All right, everybody, before we get hands-on, I think it's really important that we talk about a few quick safety rules and tips to ensure your safety. Now, William, we gotta go over there. Go over there. There aren't a ton of safety precautions that I could really think of, but there are really three main things that you should keep in mind. The first and foremost important thing is to make sure that you never complete a circuit with your hands or with wires. Never, ever, ever place one hand on a positive terminal and the other hand on a negative terminal, as well as connect positive and negative ends of wire together, especially when the circuit is live. It will spark and it could possibly cause a fire. So don't do that. The second tip, safety rule thing that I think you should keep in mind is to make sure that your connections are always sound and complete. Make sure all of your bolts and terminals are nice and tight. Not too tight, but tight enough to keep them in place safely so they won't come loose. Make sure to wrap any exposed wire or metal in shrink wrap or in electrical tape. That will help keep everything extra safe. And my third and final tip is to make sure that you are coherent and everything is well lit while you are working on electronics. Don't attempt to work on your electrical system when you are sleepy, inebriated, or agitated, because I promise you, you will make mistakes and it's just safer to be calm and aware of what you're doing. I have a funny story about a time I was connecting two batteries together in my college campus's parking lot and I made sparks fly everywhere. It was really scary. So yeah, definitely be aware of what you are doing. Do not be tired and overstudied. Yeah, that will definitely cause problems. Okay fam, back to the video. Step one is to make sure that your solar panels are somewhere where they can get adequate sun. And then when you connect them, make sure positive ends are connected and the negative ends are connected to each other. And always make sure your solar panels are nice and clean because then they can pull in the maximum amount of power. Step two is to place your battery, if you are building this in a moving vehicle, somewhere off to the side and safe. And then try to build some sort of contraption that can keep it in place. It's better to build a box around it so it doesn't pop up. For now, I just have this wood here to keep it from sliding around, and eventually I will be building a cabinet around it, so it will be a lot safer and I won't have to worry about it. If you can bolt it into your vehicle, that is also better, because if something were to happen, you don't want this to go flying around the van. Also, if you have more than one battery, this would be a good time to connect them together. Always remember that positive terminals connect with positive terminals and negative terminals connect with negative terminals in order to keep the system 12 volt. Alright, for this little side tutorial, I'm going to show you guys how to make your own cables with ring terminals at the end. I hate how expensive they can be online to buy them. Like, companies are stealing your money if you're buying cables that have ring terminals on the end of them when you can just make them yourself. So I thought, in the interest of saving y'all money and saving me money, I will show you guys how to make your own. These can be used for your battery, all of your load appliances on your fuse box, and anything that requires a ring terminal that looks like this. You can make yourself, and that is one thing I didn't know when I built out my first electrical setup, and I'm cheap, so I want to make my own. Alright, so this is what you're going to need. You're going to need some wire. In this case, I have some 12 gauge wire. Stranded is important. Some electrical tape. You can also use shrink wrap. Don't mind all of this gross, crusty stuff on it. And some ring terminals. You want to make sure you get ring terminals that match the size of your wire. Also, the little hole ring thing is the right size for whatever you're using, whatever you're going to be attaching it to. And then you're also going to need some wire cutters. I say definitely invest in a pair of these. I stole these from my college electrical circuitry lab thing. Don't do that. I recommend just buying a pair. Step one is to strip your wire, and the way I learned to strip wire is to make a little indent in it first. Now this will be more complicated with thicker gauge wire or cable, but you can use like an X-Acto knife or something to cut the first layer of insulation. And then, so yeah, I just make a little dent in it first off. And then I gently pull it off like that. There's the end stranded of your wire. What I do is I just stick it in there. Sometimes they don't come with the little insulation around the metal part. That's okay, because we're gonna cover this with some electrical tape. And then this is where a hammer is going to come in handy, or crimpers, like electrical crimpers. I like to do it the brute force way, so we're going to just hammer it. I don't know if you're really supposed to do this, but this is what I do. I take my rusty hammer that I left out in the rain. I take that, and then I just carefully hammer it. Just like that, so it's nice and tight, it won't come off. Alright, and simply next you just take some of your electrical tape, or your shrink wrap. Where is the end? I can never find the ends of these things, it's so frustrating. And you wrap it around, making sure that it's covered. I never make anything super perfectly neat, it's just like my aesthetic, so that's what we're going with. Yeah, just like that. And there you have it, guys. Your own ring terminal that you didn't have to pay for. These are really useful to know how to make for connecting batteries with bigger, thicker gauge wire, because it could be really expensive otherwise. So yeah, it will be more difficult with larger gauge wire. So here is an example of one that I made because I wanted a fuse box. And basically, yeah, it's wrapped in there, and this is with the thicker wire. And then basically all of these are going to be made myself. So make them yourself. It's good. It saves you money. Alright, back to the video. Alright, now that that is done, we want to mount everything on to a board or onto your wall. The goal here is to keep it fairly neat. As you can see, mine isn't perfect, but you want it to be neat enough that you know what is happening, and also you want it to be accessible so that you can go in and fix anything if anything ever breaks.
Once you've done that, first connect the batteries and then your solar panels to the charge controller. Never connect your solar panels before your battery bank is connected, or you might damage the charge controller. You can put an inline fuse that matches the amperage on your charge controller on the positive cable between your battery and the charge controller, and your solar panels and your charge controller. Though it is not necessary, it can help protect your hardware in the case that something weird happens in the circuit. Then once that is done, connect your fuse box to the load terminals on your charge controller. This is where you can place an optional main switch on the positive cable between your fuse box and your charge controller. I like having one because it gives me peace of mind when working on my electrical that the circuit is broken and nothing will spark.
So from this point on, things are going to look different from build to build. So I'm going to show you what I have done behind my paneling and what I plan on doing in order for you guys to get kind of an idea for your own design.
My setup is going to need to provide power for 4 LEDs, 1 LED strip, my max fan, a water pump, an inverter, multiple USB outlets, and a 12-volt fridge. This is how my LEDs are connected. I have one main tap wire for negative and positive connections. I then connect each of the LEDs by cutting into the wire and connecting additional wire to the tap wire. I do this for each of the LEDs and then add dimmers to them.
Alright everybody, for this little tutorial segment thing, I'm going to show you guys how to connect a dimmer. A switch is similar, except you are going to be only connecting the positive ends. You don't have to do the ground and the both the ground wires. So I'm going to show you the more complicated dimmer version. We're going to be adding it to my LEDs that are going to be over my couch bed, because you know you gotta have that good move lighting, you know what I mean. First of all, you want to turn off your power or disconnect your load, your fuse box from your charge controller to make sure that nothing is going to spark. So, turned off my power. I know it's so itchy, the allergies are freaking wild out here. So next, all of your connections between, your positive and negative connections between your LEDs and your like fan and stuff, it's good to have connectors. You can solder them together, which is not necessarily structurally sound, but you can do that. That's one way of doing it. I find that way more complicated. I like these. My mom actually turned me on to these. Stick your wire in there and you twist them, and that's pretty awesome. It's super simple. And then I wrap it in electrical tape, and that really seems to do the trick. I like these, but you can also get ones that I used in my last build where you stick your main tap wire and then you put on your other wire onto the top wire. I don't know if that makes sense, but there are different options for connecting. These I feel like are the easiest and fastest way. I'm rambling on about connectors and I don't know if you care, but this is how I'm going to be connecting my wires. Alright, so hopefully you could see this and you get a really close-up view of my face. So what I'm going to do is take the positive and negative wires that are going to my LEDs, and I'm going to cut them there, because we are about to put a dimmer in between. And this is kind of awkward, like I really wish I had done this before I hung everything, but here we are. As you can see, this is my little bang up job of tapping into my larger wire. But okay, I'm making the cut. I feel nervous about this for some reason. But double check everything before you cut it, and there we go. There. If I had been more planful, I would have planned for this dimmer, but what I have to do in order to get it to where I want it to be on my cabinet, I'm going to have to add wire to extend them. So I'm just gonna strip these real fast. See, twist, twist. I freaking love these twisty caps. They're so awesome, man. It makes life so easy. So I'm just adding electrical tape to all of them to make them look, or to make them secure. I twisted them as best as tight as I could so that they're nice and secure, and then electrical tape the out of it every day. Every day. Alright, mates and friendos and familia, we are going to make sure that the wires that are coming from the fuse box are separate from the wires that are going to your LEDs. So essentially you're gonna have two of each color now. And you're gonna take your dimmer, and there's going to be 4 inputs on it. This one, thankfully, is color-coded. That's really nice. So one set of them is going to be going to your fuse box, and I believe on this dimmer, the green, so this is negative and this is positive. You can see that. And this one is going to be, this set is going to my fuse box, and this set goes to my LEDs. So basically, when you're pressing this button, and it's connecting and breaking the connection between the two wires, thus allowing power to go through or stopping the power from going through. And then a dimmer is cool because it will send a different amount. It will only send a certain amount of power through, which is allowing the lights to be dimmer or brighter. So we're gonna connect those and then turn it on. Take my handy dandy little connectors and put it in. And then we're gonna just go like this and stick them in and twist them. Make the connection, make the connection. Krusty Krab pizza is the pizza for you and me. All right, and then we're gonna take the ones that go to your LEDs, and connect those. It's pretty simple. It's like, it's something that could potentially seem really complicated, but once you have it explained to you and you do it for the first time, you're gonna be like, what the heck? I'm a genius. Like, I can make magic happen with electricity, and that's cool. Like, sometimes when I'm working with electrical, I feel like a witch. I feel like a straight up witch, and you know, that's what you want out of life. You want to feel like a witch. Self-reliant witch woman. All right, those are in. We're going to turn it on. There is the potential that I reverse the sets because I don't know, but hopefully it works. So let's turn it on. Looky here, guys. It's blue. I like this dimmer because it lights up. It can be kind of annoying when you're sleeping, so sometimes I'll like put a pillow over it or something, but yeah, when you press it. And this one, you have to like hold down to dim. It's interesting. I can't wait to show you guys. It's so cool. Yeah. Before we get too excited, I turned my power off again, and we need to just double check these connections, make sure they're sound, and wrap some, oh, see, look, this one fell out, so I'm glad I checked that. And then we're gonna put some electrical tape around it, and then we're done. Then I'll show you the dimming. Okay, so I just wanted to give you one more view, just in case it wasn't clear from where I was showing you. But basically, so here are the two wires that are going up into the LEDs. Those are connected there, the red and black. And then the input from the fuse box, or in this case the main tap wire that I have going for the LEDs, is going green is negative and red is positive. And those are connected there. And when we turn on the power, it looks like this. And then we can press the button and turn it on. Turn them off, turn them on. And so I haven't connected the switch to these ones over there. I'm trying to decide if I'm going to do a dimmer or switch for those, but those are going to go over my little kitchen area there. But so now they're separate circuits. Okay, cool. So hopefully that helped you guys. Definitely ask questions down below, and I will try my best to answer them if that was confusing, but I hope that helps. All right, back to the video.
The rest is pretty simple. I am going to run wire from my fuse box behind my cabinetry and bed to reach where they are going to be located. The fridge and the inverter will be directly connected to the battery with an inline fuse matching their amperage between them and the battery. The water pump will also need a switch in order to turn the pressure on and off when you need to.
Once you're done connecting everything, you can turn everything back on. And if something isn't working, be patient with yourself. Look how far you've come, guys. Don't feel bad if you need to take a break before you start troubleshooting. Troubleshooting is something you're gonna have to get really good at. Remember, we're self-reliant badasses. Me and everyone else in this community is always here to help you. So comment down below if you have any questions about anything in this video.
I think a lot about the standard of power usage that modern humans have created. We require so much energy. If you are new to low power usage living, you will quickly see how little an individual requires to live comfortably. So much energy we use is in excess and is created in ways that are affecting the climate negatively. I am optimistic that people will begin to listen to the science and facts of how our overusage of non-renewable resources is going to affect generations to come. It is time to shift the way we use power on a day-to-day and become more connected and more aware of what our role is in the bigger picture.
Thank you so much, everybody, for watching. I hope this video can be an aid to you on your journey to living alternatively. This is my third attempt at writing and recording this electrical video because I wanted to make sure that it was clear and concise, but also packed with all of the vital information that you need to know. Comment down below if this video was helpful to you. I'm definitely open to making more videos about any of the topics in this video, and if you need me to go more in depth on anything. So thank you for watching. Comment, like, and subscribe, and I will catch you guys in the next one. Bye!